So when we are trying to work with significant figure numbers, we need to know how many digits or how many significant figures we can keep in our answer. So there are two rules for this, and the first rule is whenever you are multiplying or dividing, the answer significant figures must match the least amount of significant figures among the multiplied or divided factors, and you round off the last significant figure that you keep. Here's an example. 5.7 times 19.12. So 5.7 times 19.12 equals 108.984. But I cannot keep all of these digits because the least amount of significant figures in my multiplied factors was 2 significant figures in the 5.7. So in my answer, I can only keep 2 significant figures. So how do I represent 108.984 with only 2 significant figures? The answer for that is I'm going to have to make it 110. The reason it's going to be 110 is because the 8 causes the 0 to round up to a 1. So there are my 2 significant figures. If I wanted to keep the 108, which many of my students do, that would be 3 significant figures. This is only 2 significant figures. 108, or let's say 109, if I rounded the 8 up, would still be 3 significant figures. I have to only keep 2 significant figures in my answer because 5.7 is the least number of significant figures among the factors. The same applies if I am dividing. If you divide those two numbers, you get a really long decimal. 19.12 divided by 5.7 is 3.354385965, and I'm sure there's more, but this calculator won't show it to me. So among these numbers, I can still only keep 2 significant figures. So I will keep the 3.3, but I'll round up the 3 to 5. I'll keep 3.4. I'll round up the 3 to a 4 because the next number is a 5. So my answer here was 3.35438 ... I'm only going to keep it as 3.4. 2 significant figures in my answer because the least number of significant figures among my multiplied or divided terms was 2 significant figures. If you are adding and subtracting, the rule changes a little bit, and you don't care so much about significant figures, you care about decimal places. If I'm adding, I can only keep the number of decimal places equal to the least decimal places shown in my terms. In this case, 5.7 only has 1 decimal place. 19.12 has 2 decimal places. So I'm only going to keep 1 decimal place in my answer, and it looks something like this. 19.12 plus 5.7 equals 24.82. But I can only keep the least number of decimal places as the least number of decimal places among my terms. So I'm going to have to let that 8 be my last digit, and I'll keep it as 8 since it's followed by 2, 24.8. Subtracting, same rule applies. Here I have 5 decimal places in the 29.34567, but I've only got 1 decimal place in 86.2. Therefore, my answer can only have 1 decimal place, even though my calculator will show many more. So 86.2 minus 29.34567 gives me an answer of 56.85433. 56.85433. However, I can only keep 1 decimal place in my final answer when I'm subtracting because the least number of decimal places in my subtracted terms was 1 decimal place. So I'll have to stop at the 8, and I will round that 8 up because it's followed by 5. So my final answer will be 56.9 in this case. You can multiply or divide more than just 2 numbers, and the same rule applies. You can subtract and add more than just 2 numbers. The same rule still applies.